All right. Right. So yeah. So when you complete the chapter, you should be able to describe the 4 production processes and compute crossover points for different processes. Describe customer interaction in process design. Identify recent advances in production technology, and discuss the 4 R's of sustainability. So the objective of process strategy is to build a production process that meets the customer requirements and product specifications within cost and other managerial constraints. Right. So whatever you're doing, it's not like you have an open checkbook, right? You have a certain amount of a limit to what you can spend. So anything that you're doing, as good as your intentions are, must be developed in the confines of your cost and other managerial constraints. Oops. So there's a diagram here that and you don't necessarily have to be worried if you're a little confused or not understand it that much, because we're going to go into detail on all of these 4 processes to explain to you what they really are and where they come into play. So if you look at this diagram, let me see if there's anything added right. And we can just jump back to it. All right, if we look at this diagram, what we're seeing here is we're looking at the volume of things that you're producing here, right? And here, variety of the things that you're going to be producing. So you have high variety, right? 1 or few units per run, but you make a lot of them, right? Changes in the modules, modest runs or standardized modules, changes in attributes such as grade, quality, size, thickness, etc. But you have long runs. Long runs meaning you run your production line for a long time, so you don't have a lot of changeover. You don't change over your machine, so you can make another product. An example of that is if you're talking about, say, a chocolate manufacturer. So let's say Cadbury's, for example. You know, they have different types of chocolate. So you have your fruit and nut, you have your dairy milk, which has no fruits or anything in it. It's just pure chocolate. So if those are produced on the same production line, what we're saying, you have long runs of the fruit and nut, very long runs. And then when you do change over, you change over to the dairy milk. So you have very long runs. That's what it meant. You're not changing over the machine or the equipment a lot of times. Let me pause for 1 second. 1 second, guys. Pause for a second. Right. So when we look at the 4 different processes, we're saying that process focus is low volume, right? So process focus projects like a job shop, machine shop, printery, hospital, restaurant, those are process type operations, and we're going to look at it, right? We're going to look at them in a bit more detail. So I said not to worry about this diagram that much. When you look at, say, the repetitive process, we're looking at, say, like a Harley-Davidson company or any company that makes stuff, basically mainly motor vehicle manufacturing, that kind of thing, bicycle manufacturing. And this one, as I said, gave you the example of Harley-Davidson. Anybody knows what Harley-Davidson is? Anybody?
Bike, motorcycle.
Exactly. Right. So we're going to look at that. And then there's a product focus. Product focus is mainly basically a sort of like you're making high volumes of the same thing, right? And it's kind of like, say, Frito-Lays. You know, all they do is make potato chips. They make different flavors. So cream or barbecue, you know, so they're making and all of that, but it's still the input is still the same and the output is basically the same, other than just adding a little flavor to it. So the input is potatoes. The output is basically potato chips, but you can have a little variation in the potato chips. So that's why it's product focus, because it's focusing on making potato chips, basically. That's why it's potato focused. And then there's no mass customization, right? These are a little difficult to achieve, but every company would want to achieve mass customization. Because what it is, you're making mass, you're doing a lot of stuff, but a lot of the same stuff. And it's the stuff that people want. And it gives you the example of, say, Dell computers, right? It's computers, but what it is, you can vary the storage capacity, you can vary the case, that kind of thing. So that's what it is for the 4 processes. And I say we're going to go through that a little bit more, so not to worry. All right. So process strategies seek to find how to produce a product or provide a service that meets or exceeds customer requirements. Because that's the main thing when you're in business. You want to make money, and so you need to meet what the customer needs are or exceed the customer requirements, right? But as I said earlier, you're in the confines of your cost, so you need to meet your cost and managerial goals also. It has long-term effects on your efficiency and production flexibility, cost and quality, right? So process strategies has long-term effects on your efficiency and productivity flexibility, as well as your cost and your quality of the product or service that you're producing, okay? So as we said, there's 4 basic strategies: the process focus, repetitive focus, product focus, and mass customization. So within these basic strategies, there are many ways that they may be implemented, right? So let's look at the process focus now. We'll talk about something like a hospital. You know, your hospital facilities are organized around specific activities or processes, right? And you need general purpose equipment and skilled personnel. Let's look at hospital. You have a high degree of product flexibility, typically high cost and low equipment utilization. And we're going to get into that. Product flows may vary considerably, making planning and scheduling a challenge. So we say it's like a hospital. Remember, in a hospital, you have different wards with their speciality. You have the ICU, right? The emergency ward, they're specialists. They're those nurses and doctors who work in they're high stress, but they can deal with that. That's their skill. ICU, that's their skill. Somebody's in the chat. Let's see what's going on here. Okay. Yeah. And then you have the maternity ward. Those people are persons involved in delivering the babies, and they're specialized, right? And then you have the radiology area, and those people are the ones who look at the x-rays and all of that. So that's why it's process focused, right? Each department is dealing with different processes or different functionalities, right? But do you understand that? Just checking. Yeah, like a stop check here. But do you understand when we talk about process focus?
Yes, sir.
Okay. All right. So it's typically, it says high cost and low equipment utilization. High cost because those equipment cost a lot, and low equipment utilization because if nobody is there to do an x-ray, then the x-ray machine is left unutilized, right? Because it's not utilized 100% of the time, right? Next, we're going to look at this is the same process focus. Okay, simplified way of looking at it here. So you have many inputs. So you have your surgery area, as I said, sick patients, baby deliveries, emergencies. So all the inputs are going in. And then you have the many departments and routings, and the different outputs are patients are uniquely treated. All right, that's what it is. Low volume, high variety, intermittent processes. So that's process focus. Just remember that. Repetitive focus now, right? As we said, like the Harley Davidson company or any company that makes the same thing over and over and over, almost like even a car assembly line. They're doing the same thing. So it facilitates, the facilities are often organized as assembly lines, as I said earlier, right? Everybody knows what an assembly line is, right? Yes? Oh,
Yes,
what
sir.
Yes,
that's
sir.
what it is. All right. So characterized by modules with parts and assemblies that are made previously. So you're just basically assembling stuff. Modules may be combined for many output options. So when we say many output options, so if you're saying you can, it's all a kind of, it's all a vehicle. Let's say it's Toyota. It's a Toyota, but you can have a Camry. What other Toyota is there now? What are the new brands of Toyotas that are out in the market? Prism, I don't know. That's a Toyota, I'm not sure. A Prism or any other Toyota brand. Not brand, but type. Because Toyota is the brand. All right. So any other type of Toyota. And same thing with Honda or any car basically. Because you can have your Honda Prelude, your Honda Stream, different Hondas. But if you notice, most of them will have the same type of engine, same type of transmission. It's just the body that's a little different. So it's the same repetitive focus that goes into assembling them with minor changes. So it's less flexibility than the process focus facility, but it's more efficient. More efficient because you're basically just running almost like just on an assembly line. And here's just give you an example. Raw materials in. So multiple engine models, wheel models, they go in. And then you have the modules that came in combined, right? And you have your output. So you have many combinations of motorcycles as an example, or many combinations of motor vehicles, for example. And there's a product focus now. As we said, this one, I like the example of Frito-Lay. Facilities are organized by product, right? A high volume, make a lot of it, but low variety, as we said. So Frito-Lays maybe have 2 or 3 varieties of the chips, right? There's long continuous production runs, and I mentioned that earlier how that is. It enables efficient processes. And it's typically high fixed costs, but low variable costs. So once they've bought the equipment, and they spend a lot of money on the equipment because it's mainly specialized equipment. So once they've bought the equipment, which is high cost, and after that, the cost to produce each unit is very small. That's why the variable cost is usually low, right? And I think did we discuss variable cost in the class before? The difference between fixed cost and variable cost? Yes or no? No? Yes? No?
No, sir.
Okay, fine.
But we got fixed costs and variable costs in manufacturing alcohol.
All right. Well, we're going to touch on that some more in this class, just to let you know. All right. So generally, they use less skilled labor because it's kind of like mundane work that you do over and over and over. The same thing every day you come into work, you're doing the same thing. All right. So it's generally less skilled labor. Yeah, so we did mention the Frito-Lays. So there you go. It's kind of like almost one input, but then you have different varieties of the same output. So you see how this diagram is actually different from the other ones where you had multiple inputs going in. This one is basically the same one input going in, which is the potatoes. Let's call it just the potato. I mean, water, seasoning, and corn, same one thing going in, right? But then coming out now, you have variations in size, because you have the packaging size and all that are different. So you might have a big bag of chips or a small bag of chips, but the same potato chips. Mass customization now, right? The rapid, low-cost production of goods and services to satisfy increasingly unique customer desires. That's what's important, right? That's why it's customization. But over the years, it has grown because everybody wants mass customization. Because you usually get more for your products because you're making it for a particular group or a particular person, so to speak, but you're making a lot of them and you might have to just tweak a little bit here and there. It combines the flexibility of the process focus with the efficiency of the product focus, right? So you're running a process. So let's just say this lady, she's talking about braces. You can see a picture with braces, right? So what it is now your dentist, you can basically go to your dentist and say you want braces, right? They will go to the manufacturer, they'll say to the manufacturer, we need braces, they'll give them the drawings and all of that, right? And they'll make them in a jiffy, right? But it's going to be made for your specification. That's how things are now, right? Make it for your specification because everybody's mouth and teeth is different. So they make it for your specification, but they can make a whole lot and make it well. Basically, just show you this in terms of how things have changed over the years with mass customization. All right, the item is motor vehicle models, right? In the 1970s, you had 140, roughly 140 models. In the 21st century, 286, right? Vehicle types, you had like 18 type of vehicles. Now you have 1,212, well, the 21st century, 1,212 types of vehicles. Bicycle types, you had 8. Now you had 211,000 types. Software titles, you had none in the 70s, right? Now you have 400,000 software because there was no computers in the 70s, right? Websites, you had nothing in the 70s. Now you had 162 million websites. That's just showing you, right? I mean, an example. LCD TVs, there was none in the 70s. Now you have 102 different types of them. So that's just showing you how mass customization has improved our command stream over the last, I'd say this is what, 30 years or so, right? Again, this is what mass customization will look like. Many parts and components in there, right? So this is like, let's say the Dell computer, many parts going in, right? I have basically many outputs, but they have their different variations. So you might want a computer that has a certain storage capacity. Somebody might want the same storage capacity, but they want the highest speed. So, you know, that kind of thing. That's what this is all about. So high volume, high variety, but it has its specifications in it. So, as we said, this is the process of choice, basically. Everybody wants to get to that. So the repetitive focus, right, wants to get to mass customization. The process focus wants to get to mass customization. Product focus, everybody wants to be mass customized, going to mass customization, right? So that's what everybody is striving towards. It makes more sense that way. All right. So mass customization, it's imaginative and fast product design. There's rapid process design, tightly controlled inventory management. You need to control the inventory. I need tight scheduling. Like it's not like you're just running an assembly line where you're making the same thing every day. You need to schedule what you're gonna make. So you need to have a tight schedule. And you need to be responsive to your supply chain partners. Anybody did supply chain yet? I think I asked this question before, right? Nobody's done supply chain?
No, sir.
We talk about upstream and downstream.
No, sir.
Okay, well, you need to be responsive to your upstream supply chain. Persons in your upstream are persons who are giving you the inputs for your manufacturing or whatever facility you have. And then downstream are basically your retail who's buying your product. They are part of the supply chain. So you have upstream and downstream in your supply chain. Again, this is a nice one page to look at that explains the four processes: process focus, repetitive focus, product focus, and mass communication, right? So to remember them easily, basically when we talk about process focus, talk about a hospital, right? And we talk about the wards, the different wards. Repetitive focus, talk about Harley Davidson or a car manufacturing plant, right? When you talk about product focus, nice to remember Frito-Lay's potato chips, right? And when you talk about mass customization, you can look at a notebook, a computer, or a PC, where you have certain inputs going in and you have computers coming out, but you can vary for whatever specification of a person wants. But you don't, listen, if somebody tells you that they want, say, a certain specification and you don't make that specification, too bad. You run certain, remember one time it was 8, 16, 24, what was it, megabytes, or I don't remember now, a certain specification, you could only get it in multiples of whatever, right? So even though it's the same computer, you could get different specs, but the specs are for only a certain amount or type of specs, right? So it allows for the mass production of that particular computer, just that you can vary between certain things or certain what you call it now, certain attributes of the product, right? What I got this? I believe this picture is in the text. I think I took it from it. I think it's there. But this is a good way to understand it. Now there's a comparison of the processes, right? Comparison of the processes, and we'll just go quickly through a couple of them. I won't do all of them because it's about 7 slides with just comparison of the processes, which you can read upon. Process focus, as we say, it's low volume, high variety, right? So you make small quantity and large variety, right, of product is produced, right? The equipment used is all purpose. Remember, we're talking about a hospital for this one, eh? If you think about it. And then for the repetitive focus now, right? Long runs, right? Usually a standardized product with options produced from modules. So if you remember the assembly line, repetitive process, and special equipment used in an assembly line, special equipment, obviously, probably you don't use in most other industries. And for the product focus, and for something like the Frito-Lay, potato chips, make large quantities, very small variety of products are produced. And the equipment used is a specialized equipment. So we're bringing specialized equipment to basically cut the potato in a certain slice. And nowadays the slice is very thin, right? And shape it a certain way, basically. Mass customization is high volume because it's mass, right? But the variety, it says high here, but it's not that high, but you want it to be high. That's what you're aiming for. That's why it's mass, right? The large quantity, a variety of products are produced, rapid changeover and flexible equipment, right? And we can go on and on and on in terms of the type of persons who work in the different processes. So for this one, for the process focus, operators are broadly skilled, right? There are many job instructions because each job changes and is different. The repetitive focus, employees are modestly trained. Repetitive operation reduces training and changes in the job instructions. For product focus, operators are less broadly skilled. Work orders and job instructions are few because they are standardized, right? Yes, they're standardized. And for the mass customization, They're flexible operators, and they are trained for necessary customization. Right? They're better trained. And custom orders require many job instructions because there's a variety of stuff that you're making. So you need different job instructions. And we could go on and show you the differences. For the process focus, the raw material inventories are relatively high, right, to the value of the product. A repetitive process is JIT procurement techniques are used. Anybody knows what JIT is? Did I mention this last class? JIT, anybody?
Yeah, just in time.
Just in time, right. The raw material inventories are low for the product focus, right, relative to the value of the product. Raw material inventories are low. And for mass communication, raw material inventories are low relative to the value. So most of them, the raw material inventories are low, except for the process focus. Right? And when it's personalized, you guys can read through that and see the differences with the different processes. All right, focused processes, right? Focus brings efficiency, right? Once you focus, you're more efficient. And focus on depth of product line. So you're going to be focusing on the depth of your product line rather than the breadth. So you're almost like you're specializing rather than making everything a whole lot of things, right? So you can focus on your customers, you can focus on your product, you can focus on your service, and you can focus on your technology. To worry about that. So to change your process from, say, let's say repetitive focus to mass customization can be difficult. You don't have the expertise in it, and it can be very expensive. So it may mean you have to start all over again, and you don't want to do that because it's going to cost you. So process strategy determines transformation strategy for an extended period, right? So once you plan to change your process, you want to look long term, 5 years and beyond. You're not changing your process for a week or a month or a year. You must look at it long term if you plan to change your process. So that's why it's important that you get it right. Okay. So let's look at crossover charts now. This is where fixed cost and variable cost comes into play. All right. All right. So since you've done fixed costs and variable costs before, so your fixed cost is the cost that you would spend every month. So if you rent a facility, you have to pay rent or mortgage every month. If you lease it, same thing, right? So that's a fixed cost, right? What's also a fixed cost is, let's see, factory setting, what else could be a fixed cost? So we talk about the mortgage, we talk about the rent, if it is rent, those are every month, that's the same amount you're gonna have to pay. If you take out equipment, right, then, and you're paying for the equipment, then the amount, if you took out a loan to buy the equipment, then you're gonna have to pay about that loan, that's a fixed cost, right? Your variable cost now, the variable cost is gonna depend on how much of a widget how many widgets you're making. So if you make more widgets, your variable costs will be more. So per unit, so every time you make more units, your variable cost goes up, right? Everybody understands that, right? Between fixed costs and variable costs. The fixed cost is always the same. So that's why you can see here, the fixed cost is a straight line, right? So we're talking about process A, which could be any process, basically, process focus. This is repetitive focus, and this is, say, probably a high volume, low variety, which could be mass customization. So for mass customization, you can see, or for process, basically, you could see that the fixed cost is higher than these two fixed costs. Everybody following me so far? Fixed costs every month is going to be the same. If you call this time, every month, your fixed cost is going to be the same. This is your dollar sign here. So your dollar is on your vertical axis, right? So once you start producing, your fixed cost is going to be going up, because you're going to be producing more. of whatever it is that you produce. So I said, I told you guys what widgets were, right? Yes, no?
No, sir.
Yes, sir.
Okay, so a widget is anything that's tangible. A widget could be a telephone, a fan, a doorknob, a television set, a radio, a light bulb, anything tangible that you're producing. All right, that's what a widget is anything tangible, right? So a factory manufactures widgets. So is any number of units that is produced, type of thing that is produced. So let's say you're looking at process A, right? And you might want to change to process B, or you might want to change to process C. What we're looking at here is what's called your crossover chart. So if you have your fixed costs here, down here, let's just, for example, this is fixed cost here, 200,000. And fixed cost here for process B is 300,000. See the straight lines, horizontal lines. For process C, the fixed cost is 400,000, which is higher than the other fixed costs. But look at what's happening to your variable costs, right? These are your variable costs. So let's look at for A, right? Right here, the blue line, right? That's your fixed cost. And for B, I think one more shift should bring it right. For B, let me take this back out so it's not confusing. For B, here's your fixed cost here, right? What is following this so far? The fixed cost for B is at, say, the 300,000 mark. So that's going to remain constant, horizontal line. But look what happens as the volume goes up. As you start making more product, then your volume is going to go up, or your fixed or your variable cost is going to go up. All right. But it goes up less than at a rate which is less than the rate of the one which is lower fixed cost, because your unit, the cost per unit for this one is much less than the cost per unit for here. So that's why it's flatter, right? Slope is flatter than the unit cost or the variable cost for process A, right? So what this is trying to tell you is at what point you can move, you make sense to move from process A and go to process B. That's what this is trying to tell you. And it's going to be at this point where it crosses over, which is why it's called your crossover chart. Okay, so where the two variable costs cross is going to be the point at whatever volume you're making. See, volume of widgets. So this could be, I don't know, this could be, let's say 20 widgets. Everything is fine here up to 20 widgets. And once you reach 20 widgets, you're going to move from process A to process B. Okay, one more click. But then there's also a crossover point, because there's three processes you're looking at. So here you go now, your crossover point, because you've crossed over from A to B. And so now you're doing marketing and you're doing well. What happens now is now you have a new crossover point. So you're moving from V1, which is the first crossover point between process A and process B. And then there's another crossover point between process B and process C. That's clear enough? Body understand that? How you change from one process to the next, it has to do with your crossover point and at what volume does it make sense to cross over. Now there's an example. There's an example that we're going to be looking at. Yeah, we said all of that is fixed costs. An example in your text. Okay. And these are always going to come on your exams or next test, always. Kevlar Enterprise would like to evaluate 3 accounting software, right? Product A, product B, and C, to support changes in its internal accounting process. The resulting processes will have cost structures similar to those shown in figure 7.3. So this is figure 7.3. So the cost of the software for these processes are, so software A, it has a total fixed cost of 200,000. The dollars required per accounting report is $60. Whoops, $60. software B. And then when you say per accounting report, you know you're talking about variable cost here, right? The software B, the total fixed cost is 300,000, and the dollar required per accounting report is $25. See, it's getting less because you've spent money on your equipment, which is your fixed cost. So the cost per unit is now less. By the way, you guys are second year or third year students in general, most?
Third year.
Third? Okay.
Third year.
Third year.
Okay, good. So software C now, right? The total fixed cost, 400,000. Then what do you expect to happen with your cost per unit? Less, right? Because you're spending money on your equipment or your fixed cost. That's what's happening. So solve for the crossover point for software A and B, and then a crossover point for software B and C. See how we do that. Simple. It's very easy, guys. All right. So I think I did a particular recording on this because some persons are having difficulties. So, but anyway, so software A yields a process that is most economical up to a point V1, but to exactly what number of reports or volume basically is the number of reports you're talking about, which is your V, right? You want to know up to what point you would keep software A, right? That's what I would say. It's crossover point. What volume do you cross over to software B? So to determine the volume V1, because that's what you need to find, because that's a crossover point, because both of them will have the same cost at that point. So we set the cost of software A to be equal to the cost of software B. So now we're going to set up an equation because the total cost will be the same, right? Because right at that point, they're going to cross over. So V1 is unknown, right? You don't know. That's what you're trying to find. What's that volume? So your fixed cost for software A is 200,000 plus your variable cost per unit, right, is $60 per unit times the number of units, right? It's going to be equal to the 300,000 for the fixed cost for B plus the variable cost, which is $25 per unit, times that number of unit, which is V1, same V1. And you just solve for V1, right? Everybody see this? So you solve for this? Bring all the V1s over. So if you take this over, it's 60 minus 25, that gives you 35. So 35 V1, and then you take the 200,000 over, so it turns into a negative, right? Simple math. Right? So 35 V1 is equal to 100,000. So you can solve for V1, it's just 100,000 divided by 35. So you can calculate where your V1 is, right? Your volume 1. What volume would you cross over at? This means that software A is more economical from 0 to V1, which is 2,857, right? Reports. Right. Similarly, to do the crossover from V2, crossover for V2, we set the cost of the software B equal to the cost of software C. So 300,000, right, plus 25 V2 is equal to 400,000 plus 10 V2, and you solve for V2 again. Simple. Anybody not getting it? Say it, please. So everybody's getting it. Good. All right. So let's look at process analysis and design. So in process, so you need to look at if the process is designed to achieve a competitive advantage, right? Because again, you're in business, so you need to have a competitive advantage, right? Does the process eliminate steps that do not add value? Because anything you're doing, right, in a process, you want to be adding value, right? Does the process maximize customer value? Because that's what matters, is the customer that's purchasing the widgets that you're producing, right? So it must maximize the customer's value. And will the process win orders? Because if you're not winning orders and you're producing and all you're doing is storing it in inventory or in your office, that does you no good. Right? So process analysis and designs. We're going to be looking at flow charts that shows the movement of materials. We're going to look at time functioning mapping that shows flows and time frame, right? And there's two others that we're going to look at too. And this is a time function map, just to let you introduce you to it. I'm sure most of you have never seen one of these. So let's just look at it. So what this is, you can look at your baseline of any product. Say this is a product, a widget then, or widgets. The customer orders the product, so it's here. Take 12 days, right? 12 days. Sales process the order. Will take you 12 days. So the customer orders it right away, right? But then it takes 12 days for sales to process the order, which is bad, right? It goes to production, control the order, and then they have to wait 13 days before it comes out of the plant because you're manufacturing what the customer orders, right? Then you need to, well, this says print, depending on the process. Your print in the warehouse, WIP, work in process, right? So from the warehouse, you go 14 days because it's work in process. Then it go to plant B. So you move from two plants, from plant A to plant B. So it produces something in plant A, then, and it's just a work in process, but then it has to move to plant B, right? More work in process again, right? Then you move it again, take another day, and you have to wait here, take 10 days again, work in process, and it's extruded back to the same, back in the same plant, it's extruded. It's just processes that are taking place within plant B, but it's plant B that's going to make it because it's extrude plant B, right? You wait, and then you move it, and then the customer finally receives it. Over here, the whole process took 52 days from the time the customer ordered the product to the time it was manufactured and got back to the customer, 52 days. So what you can do with something like that is you can look and see where you can eliminate some of the steps, right? To reduce the time, because then ultimately that's what you want to do, right? So here you've eliminated a couple of the steps, and basically you probably combine and put everything in one plant. Here you have this plant right here. So from the time the customer orders it, day one, to the time they get it, it just takes 6 days. So you've knocked off, what's that, 46 days out of the total process time, right? So that's what time function mapping can help you with in terms of time. Try to look at the process and see what you can do to reduce your time. So that's called it's called time function mapping, all right? We're just introducing you to it, not to worry. We won't ask anything on it. It's an introduction, so you know it. You have it in your arsenal of things that you can use. So process analysis and design, we continue. So we're talking about flow charts, and they show the movement of materials. Time function mapping shows the flow and time frame. We just showed you that. But there's also the value stream mapping that shows the flow and the time and the value added beyond the immediate organization. So it goes out to the organization. Everything and the other ones stay within the organization. This one, value stream mapping, goes even out to the customers. Process chart uses symbols to show key activities. And service blueprinting focuses on the customer provider interaction. So let's look at a couple as introduction. So this is the value stream mapping. What this would be. And again, you have the days and how long it takes every operator to do certain task, basically, right? Again, we're just showing you what it will look like in terms of value stream mapping, but we don't usually emphasize this or put calculations on tests with the value stream mapping, but introduce you to it so you have an appreciation for it. Okay. All right, so let's move on from that one. Process chart again. So I worked with this when I was at Cadbury's in terms of process charting, where you have different symbols for different things. So here's just look at meat patty storage. You move it to transfer to boiler, which is here, right? So 0 or circle is an operation is gotten done. Arrow is your transportation. They're moving the item. A square is that something needs to be inspected. D is a delay in your process. And that upside down triangle is the storage. So you move the meat patty from storage, right? You're gonna transfer it to the boiler, right? And at the boiler, some operation gets done. See, operation gets done there. And then it is moved for inspection. It's inspected. And it tells you how long the inspection takes in minutes. This is 0.5 minutes for inspection. Well, a short time. Then it goes to be transferred to rack. So it's a movement. That's why it's under transportation here. See it? Moves to temporary storage, right? Then you get your buns, your lettuce and stuff to put on. I think you're doing an hamburger assembly process, right? Right here. It moves to the assembly order, then it's placed on the finishing rack, and I guess the persons in the restaurant takes up the hamburger and sends it out to the customer. All right, so I did a lot of this kind of stuff. Early days at Cadbury's. Service blueprint focuses on the customer and the provider interaction. Defines 3 levels of interaction. Each level has different management issues. Identifies potential failure points. Again, this one is just to introduce you to what it looks like. So they're getting the 3 different levels. Level 1, level 2, level 3. Level 1 basically is customer. Level 2 level 2, you're still interacting with the customer. Level 3, you're actually just in your own organization, and you move everything back up to level 1, where the customer is, to make sure the customer gets what it is that they've ordered. All right. So again, it's an introduction to service blueprint. So analysis tools, the flowchart provides a view of the big picture, right? Time function mapping adds rigor and a time element. Value stream analysis extend to the customer and the supplier, that's interaction. The process chart shows details, and the service blueprint focuses on the customer interaction. All right, special considerations for service process design. Some interactions with customers is necessary, right? But this often affects performance adversely. So the less time you spend with customer, they're saying, is the better it is for you, right? So the better these interactions are accommodated in the process design, the more efficient and effective the process is. You need to find the right combination of cost and customer interaction, because it's pointless to just keep spending money on service, right? Because you can spend forever. So you need to find the right balance of cost, what it's going to cost you, and how much customer interaction there is. This is just basically what we call a service process matrix. So here it shows the degree of customization, and here the degree of labor required. So I think we had looked at an airline one the last class. So no frills airline, basically degree of labor. Sorry. No, let's not look at this slide. I should have taken that out from before. All right, so mass service and professional service. That's out of it also. Right. All right, so we're looking at improving service, productivity. So the strategy is separation. So structure service. So customer must go where the service is offered, right? The structure so they must go where the service is offered. An example of this, bank customers go to a manager to open a new account, to loans officer for loans, and to tellers for deposits. So you basically set it where the structure of service, the service is structured in such a way that the customer must go where the service is offered. Because one of the benefits of that is that whoever is offering the service becomes a specialist in it. Because if it's loan, they're the manager is now the expert in that. If it's a new account, they're the expert. If it's a loan, the loans officer is the expert. And if it's deposit, because maybe if you ask the bank manager to go over to the teller area, they probably won't even know how to collect the funds and where to put it, how to maneuver that particular account screen. But if you ask them about opening up a new account, then they're experts at it. So you structure the service so that the customer goes where the service is offered. Self-service. So self-service. So customers examine, compare, and evaluate their own pace. For example, supermarkets and department stores, internet ordering. I'll go as far as gas stations. We don't have any self-serve gas stations here in Jamaica, though. But that will be one of it. Postponement as a strategy. Technique, customizing at delivery, for example, customizing vans at delivery rather than at production. So you don't customize the van on the production line. You wait until it's delivered, or you wait until they come into the sales office and ask that the van be customized. Then you do that there, but they'll have to wait. That's why it's called postponement. Because they want certain things on the van, and they're gonna have to wait. But you're gonna have to call back to the manufacturing plant, get whatever they want customized, and then get it to here. That's why it's called postponement. You're gonna have to wait. So I want to go back. Focus, restricting the offering, right? An example of that is a limited menu. You go to some restaurant, they only serve certain things. So, you know, they don't want to be jack of all trades where they have a huge menu, right? Because if you have a huge menu, one, you're probably not an expertise at making all the dishes on the menu. And two, it might take you too long. But if you have certain items or certain things on your menu, then your inventory of what you need to pack is there. You know, it's just not as a wide menu. If it's just chicken on your menu, and all you need in the inventory is chicken, right? You don't need beef, you don't need pork, all of that. You just need chicken. So your focus. Modules, modular selection of service, modular production. An example, investment and insurance selection. Prepackaged food modules in restaurant, right? So like if somebody orders an order of fries, you know exactly what that order is, right? Because you know how much fries goes into that because it's pre-packed and it's in modules, right? Automation, separating service may lend themselves to some type of automation. An example of that is automatic teller machines that we've seen now. And you're wondering what we'll do without them now, eh? Scheduling, precise personnel scheduling ticket. An example, scheduling ticket counter personnel at 15-minute intervals. So you'll see some places where you have to pull a ticket to get your service, right? And they'll call your number at that time. So that's one of these examples. Training, clarifying the service options, explaining how to avoid problems, right? So investment counselor, funeral director, after sales maintenance and personnel. I guess in this case, you're talking about training your staff to do after sales maintenance, and you train them to do that. So improving service processes, your layout is important, right? Your product exposure, your customer education, your product enhancement. So depends on where how you position your product that can improve your service to your customer. You educate the customer so that they know what the product does for you. You might put up we call it not a billboard, but it's just a signboard to say, you know, how many calories is in something, that kind of thing. That helps in terms of improving your service. The human resources, you need to recruit and train the right person. So recruiting and training, very important. And the impact of flexibility cannot be understated. Flexibility, very important for your staff to be flexible, so they can work in almost any area of the organization. That always helps. But that also helps with job enrichment and that kind of thing also, which you've learned in a human resource course. Equipment and technology, often complex decisions to make, right? Because they're changing so fast. But you get possible competitive advantages with equipment and technology, flexibility, and you have stable processes. May allow for enlarging the scope of the process. Technology will do that for you, and good equipment will do that for you. So when you thought you could only make possibly one type of product, technology will allow you to be able to make more types of products. So got production technologies now, machine technology, automatic identification system, AISS, process control, vision systems, robots, automated storage and retrieval systems, automated guided vehicles, flexible manufacturing systems, computer integrated manufacturing, CIM. So machine technology increases your precision, right? Increases your precision, increases productivity, increases flexibility, improved environmental impact, reduce change over time, right? That's what new machine technology can do for you. And it can decrease the size of your labor force and reduce your power requirements, because every time new machine comes out there, they're rated with using less power. The automatic identification system, improve data acquisition. This is where I think this is one way to scan. You have barcodes on it, I believe. Yeah, barcodes and RFID, and you know, scan like in the supermarket, right? So it improves your data acquisition, reduces data errors, increases speed, increases scope of process automation. Process control, which is real-time monitoring and control of the processes. And if you do your advanced operations management, we go in detail in process control, where your processes within control or it's spiraling out of control. We go into a lot more details there. So sensor collection data, sensors collect data, right? Devices read the data on periodic basis. Measurements translated into digital signals and then sent to a computer. The computer program then analyzes the data and gives you an output, right? Vision systems, particular aid to inspections, consistently accurate. Not like somebody having to look at something all the time, as was once the case. You know, vision systems is never bored, right? And it's a modest cost now. The cost of these things have come down significantly and superior to individuals performing the same task, obviously. Right? So that's the vision systems. Robots, as you know, robots is now a big thing in auto manufacturing. environments. I remember when I went to Japan years ago, many, many years ago. But when I saw the robots working, I'm like amazed. And then I went to California. Was it California? No, it was Vegas or California. I don't remember where it was. It was Vegas. And there's this bar. Believe it or not, guys, there's this bar with robots serving drinks. Well, they're not serving drinks, but it's on a conveyor belt. So you enter the drink that you want, and you can see the robot actually mixing the drink for you, right? I mean, you're gonna have to stand there and collect it, but it's not like the robot walk over to you or anything like that. But you can see the robot mixing the drink, and then you can just take the drink. It's amazing, amazing. So robot dangerous task. They perform tasks requiring significant strength or endurance, and the robots generally enhance consistency and accuracy, because they will pour the same amount every time in every glass for a specific drink. Automated storage and retrieval system. So automated placement and withdrawal of parts or products. Anybody who works in a warehouse will know that nowadays, and you've seen it on TV, especially the Amazon warehouse where everything's automated, right? Reduces errors and labor, and particularly useful in inventory and test areas of manufacturing firms. These are automated guided vehicles now, electronically guided and controlled carts, and used for movement of products or individuals. And SIM, computer integrated manufacturing now, extension of flexible manufacturing systems, backwards to engineering and inventory control, forward to warehousing and shipping, right? That's the computer aided manufacturing. Most big manufacturers now use CIM, right? Can also include financial and customer service area. Reducing distinction between low volume, high variety, and high volume, low variety, which is so you can look at your mass customization here. This kind of environment will allow for computer integrated manufacturing. That's the mass customization. There we go. This is just a diagram of some of the stuff that we just looked at a while ago. Yes, second. Wow. Here, we're not too far off, guys. I know some of you are bored, but it's what we have to go through. All right, technology and service. In financial service, you have a debit card, electronic fund transfer, ATMs, education, electronic bulletin boards, you have whiteboards. Give me a second, guys. Hello. Sorry, guys. Oh, stuck. Yeah. In education, technology, we're talking about Blackboard and smartphones now. Utilities and government, you have automated one-man garbage truck. We don't have that yet in Jamaica. Optical mail and bomb scanners, flood warning systems. Meters allowing homeowners to control their energy uses. We have those, guys, and cost. Restaurants and food area, wireless orders from waiters to kitchen. Robot butchering, transponders and cars that track sales at drive-thrus, communications. You have interactive TVs now, we have ebooks, Kindle, that kind of stuff. We're looking at technology in service because earlier we looked at technology in production, right? We're looking at it in service industry now. So in hotels, you have electronic check-in, check-out, electronic key lock system for your door, and mobile web booking, and so on and so on. I mean, it goes on and on and on, which you can see it. All right. Process redesign. So the fundamental rethinking of business processes is to bring about dramatic improvements in performance. That's why you redesign processes, right? So it relies on reevaluating the purpose of the process. So you look back at what's the purpose of the process and questioning both the purpose and the underlying assumptions. It requires a re-examination of the basic processes and its objectives. It focuses on activities that cross functional lines. Any process is a candidate for redesign. So if you redesign it yesterday, you can come back and look at it today again and see if you can redesign it, right? So any process is a candidate for redesign. Sustainability, and these are the 4 R's that we say you must know at the outset. Sustainability in production, in the production process, for resources, recycle, regulations, and reputation. Let me see if we have it here. For resources, operations is the primary users, and reducing use is a win-win for everybody. So you want to reduce the amount of resources that you put into your production. Obviously, it will cost you less, right? Recycle, you want to bury, burn, or reuse your waste. And recycling begins at design. So once you're designing something, you start to think, what are you gonna do with the waste? How are you gonna recycle the waste, right? And that's for sustainability. And that's a big thing now, guys, in operations, production operations management. So resources, recycling, and regulations. So laws affect, it's not just transportation, let me say this. You have environmental laws, right? Which deals with waste and noise. So your noise can't be more than a certain decibel level. Decibels measure is a measure of sound, eh, guys? So if you're having a party, somebody can come up with a decibel meter and say whether your sound system is too loud for a specific area. So that's regulations there for you. And you know about, we're going to talk some more about it, effluents into the streams, like streams that Kobe River, stuff like that, waste. Your emissions into the atmosphere, that kind of thing also is governed by regulations. So who deals with regulations of environment here in Jamaica? Anybody? You're not sleeping yet? Anybody?
NEPA, sir.
NEPA, exactly. Right? And what's happening now, why production operations management is becoming so much more involved and important is some of these more regulations are always coming out for different reasons, you know, regulations that companies will have to abide by, right? And it's the operations and production operations management person who has to ensure that you're within the regulations, right? Because there's increasing pressure year after year after year to do better. Cut your carbon emissions, your carbon footprint, all of that kind of stuff. Reputation, you want to make sure that your company has a good reputation. As leaders may be rewarded, but bad reputation can have negative consequences on your company. Okay, that goes without saying. So those are the 4 R's, guys. What we had for a study guide. I'm just trying to remember. When I look back at the test just to make sure that, let's see. Right, this is for test 2. Right, all right. So we'll come back to this if needs be. I don't think this is on the multiple choice. But I will check the multiple choice and let you guys know. So we've covered, just to know that we've covered it. It's not on it, that's all right. All right, so that's where we ended tonight. Let me stop share my screen and look at something, all right? Don't leave, let me just look at something just to make sure. All right, guys, you there? All right. So, all right, so we are done for tonight. The test is at 5 o'clock on Sunday, but I'm going to have it. It's going to be up before that. Instructions and all of that, but you don't need because of multiple choice. Just to let you know, I just did a quick review of it. As I said to you before, oops, take off my, 1 second. Are you guys still hearing me?
Yes, sir.
All right. Oh, I see it. Okay, good. Second.